Okay, in the last class we have discussed about the various high power devices, how to control the high power devices using microprocessor. Today we will discuss about the stepper motor interface to the 8086. So, stepper motor, unlike the conventional motor where the rotation will be continuous, here will be having some steps. So, stepwise rotation will be there, because of that this stepper motor will be used in printers. Okay. So, if the number of teeth in the motor is n, you can choose the n, depends upon your application. Okay. And there will be 4 windings, number of windings will be 4 motor windings. If I call these windings as W4, W3, W2, W1. So, in order to rotate this stepper motor, the sequence that has to be given to these windings will be 0 0 1 1. You have to feed 1 1 in 2 windings, you have to feed 0 in 2 windings. Then you have to rotate this to the right. If I rotate this, this will come in front of this, and this will move here, this will move here, this will move here, and so on. So, this becomes 1 0 0 1. Till you get the same first sequence, we have to do this rotation. Then the next rotation 1 1 0 0. Next rotation 0 1 1 0. Next rotation is 0 0 1 1, which is same initial rotation. This is the initial sequence. So, you see the way you have to give the sequence if you want to rotate stepper motor in clockwise direction. If you want to rotate in anti-clockwise direction, you have to give in a reverse manner. You start with 0 0 1 1, then you give this 0 1 1 0, and so on. So, we know how to control these motor windings. They require the larger currents. So, I will draw now the interfacing circuitry between microprocessor and stepper motor. So, correspond to each winding, I will connect to one of the ports of 8255 through the control circuitry. So, the interfacing diagram of the stepper motor to 8086 is as follows. So, this is 8255, we have 4 windings as I have told. So, you have to connect through the buffer. This is a bootstrap. As you have discussed in the earlier classes, this will be used to increase the current capacity of the circuit. This is the winding. This is to one winding. Let us call this one as W4. So, these values is going to decide. This is something like 470 ohms, 620 ohms, 2 kilo ohms. Similarly, we will be having correspond to W3, W2, W1. This is one of the configuration that I have discussed to increase the current capacity. Similarly, third one. And fourth one. So, there are 4 windings, correspondingly the 4 control circuitry. So, these 2 transistors will be used for increasing the current capacity. This will be connected to the motor winding. So, these are values are same as the previous 2K, 620, 470 ohms. This one is winding W4. This is W3. This is 620 ohms, 2 kilo ohms. So, these points will be grounded. This is W2. This is W1. These are called motor windings. In the last class, we have discussed about how to control the motor winding also. This is the circuit that we have discussed. And these points we have to connect to plus 5 volts or plus 12 volts, depends upon the specifications of the motor. We can have 12 volt operated motors also, and we have 5 volts operated motors also. This will be given to common plus 5 volts or plus 12 volts. This is the complete circuitry which has to be connected to the windings of the stepper motor. The other side we have to use the 8255. So, these are all called buffers. There are 4 buffers. So, we know the buffer increases the current capacity. So, this I am going to connect to 8255, one of the ports of 8255. Only 4 pins of 8255 is enough. So, it is up to you. I am going to connect this W1 to PA0, PA1, PA2, PA3. So, I will assume the same addresses. Port A address is FCH, port B is FD, port C is FE, and the control word is FFH. So, what will be the control word corresponding to this one? I am using only port A. I have to program as output port. So, in order to program all the ports as output port, ATH is the control word. Okay. So, if I want to write the program here, so the program procedure is, so I want to operate this motor at a speed of These are the specifications. So you have to first decide the specifications before writing the program. Interfacing is same. Okay. How much delay is required between two consecutive sequences? As I have discussed that. So the sequences that you have to give is 0 0 1 1. So then 1 0 0 0 1, 1 1 0 0, 0 1 1 0, 0 0 1 1. Like that you have to repeat the sequence. Okay. In between the two consecutive sequences, what should be the delay? That depends upon the speed. So the specifications are the speed I want to use a speed of, this depends upon the application, say 12 RPM, revolutions per minute or rotations per minute. I want to rotate this. Say number of teeth will be, say n is equal to 200. Number of teeth is 200. So 12 revolutions per minute. Per second, how many revolutions? 12 revolutions or 12 rotations per minute. Implies 60 seconds will be 1 minute. So in 1 second, how many rotations we want? So we want 5 rotations per second. And number of teeth is 200. So means one rotation will be, have to rotate, one complete rotation means 200 teeth. 200 teeth is equivalent to so 5 rotations per second. One rotation means 1/5 second. It has to get 5 teeth in 1/5 rotations. 200 teeth has to be completed in one rotation. So 5 rotations, for 5 rotations how much time is required? 5 rotations. What is the time required? Will be 5 by 1 into 200, which is equal to 200 by 5. This is equal to 40. So 40 milliseconds is the time required between two consecutive states. So I have to write for this particular delay. So we know how to write the delay programs. Now if I come for this overall main program of this stepper motor, the program part. First you have to program all the ports as output ports. For that, so initialization of a data segment that I am not writing now. Move AL comma ATH out FFH comma AL. These two instructions are used for programming all the ports as output ports in mode 0. Then the sequence that I have to give is, so I want only 0 0 1 1 sequence first initially 0 0 1 1. The logic that I am going to use here is, so I will write 0 0 1 1 also again. I will repeat this. You see nothing but 3 3 H hexadecimal I am going to enter into AL. Okay. So after each rotation what happens? We are going to rotate this to the right by 1 bit position through carry. So after the first rotation what happens? This will becomes 1 0 0 1 1 0 0 1. So this bit will come here, this bit will come here, this bit will come here, like that. So this bit, last bit will goes to the first bit. So this 1 will be comes to here. So this will be the sequence after the first rotation. So after the second rotation in a similar manner, so this bit 1 will come here, 1, the remaining all these bits will be shifted to the right by 1 bit position. So what will be this one? 1 0 0 1 1 0 0. This will be after the next rotation. Next, like in a similar manner, 0 1 1 0 0 1 1 0. Next will be 0 0 1 1 0 0 1 1. So next one will be 1 0 0 1 1 0 0 1. Next one will be 1 1 0 0 1 1 0 0. The next one will be 0 1 1 0 0 1 1 0. So next one will be 0 0 1 1 0 0 1 1. This is same as the initial sequence. These two are same. Means after the 8th rotation, so you will get again 33H. You take 33H in AL register, it goes on rotating 8 times. After the 8th rotation, again you will get the same 33H. Okay, that is why I am going to take this 33H. Move AL comma 33H out port A, because I have to give this, I am connected these to W4, W3, W2, W1. So the sequence that I have to give is 0 0 1 1 1 0 0 this. Again this is same as this. Again here this is same as initial. So this sequence will be repeatedly comes. So you have to output this onto the, because this W1 is connected to PA0, this is connected to PA1, this is connected to PA2, this is connected to PA3. So if out onto the port A whose address is FCH comma AL, what happened? The first sequence is given, so it will rotate. Then you have to give this sequence in the order. Between the two consecutive rotations we have to call some delay, the delay which you have computed earlier called delay. This depends upon the speed that we want, the speed at which we want to operate the stepper motor, and I explained the procedure to compute this delay. Then after this we have to send this sequence. For that we have to rotate this value to the right by 1 bit position. Okay. So for that you write the expression for RO R AL comma 0 1. So this last bit will come to the first bit. Then again you output the same sequence. So for that unconditional jump to up. If I write up here, so in the first instant this is the sequence. So after this rotate instruction, this is the sequence. Okay. If it goes on giving the sequences, you will get this. So here after this 4 signals you will get the initial state. Again after another 4 you will get the same as this initial also. This is an infinite loop. So this will be continuously sends this sequence of 0 0 1 1 1 0 0 0 1 0 0 1 1 1 0 0 0 1 1 0 to the 4 windings. Thereby the motor will rotate at the speed that is decided by this delay. Okay. This is about the program to rotate the stepper motor through 8086. So next we will discuss about how to measure the water level and how to control the level of a water in a tank. Water level control using, in many of the industrial applications this type of control is required. So in the previous stepper motor control we have driven this rotor winding. Now we will discuss about how to control the motor. So here we can have this different ways to measure this level. So this setup that I am going to use here is, this is the tank where I want to control the level. So, this tank is grounded and we have the water level up to this point. Inside this you have to insert a probes. So, you have to insert probes through the resistor values. So, here we have 5 volts. You take the resistor values. If I use 8 probes, this we have to connect to the inverters. Through inverters I am going to connect to the ports of 8255. So, what is the need of inverter? I will explain. I am going to use one complete port of 8255. This is your 8255. Let us assume that this point is connected to a probe here. This point is connected to another level. So, I am going to measure here 8 different levels at equal distance. This to another level. This to another level and so on. This I will connect to PA0, PA1, so on up to PA7. So, this is the minimum change in the level that is required to detect. This should be same. Okay. So, we can display the level as well as we can control the motor also. Okay. So, in order to control the motor, something like this is connected to 20 volts AC. This is motor. And this will be also controlled by 8255 port. I am using port C, PC0. So, this motor will be on or off using this PC knot, thereby it will pump the water into this tank. Now, we can send this value to the another port. I am using port B. To send the data to the display. Through BCD to 7 segment decoder, you can use 4 pins of port B, lower order 4 bits, PB0, PB1, PB2, PB3. This is 7447, which we have discussed in earlier classes. VCD to 7 segment decoder. The 7 segments will be connected to the each segment of 7 segment decoder. Of course, through resistors. Here I am assuming that the water level is only a single digit. It can be 1 centimeter, 2 centimeters, on up to it can count up to 8 centimeters for the sake of simplicity. We can extend the same logic to connect to a multiple digit values also. Okay. So, the basic assumption here will be now, suppose a particular probe, these are all probes, these are all probes. If a probe is inserted into the water, what will be the voltage level? Is immersed. So, what happens? There will be connection from this water to the tank, which is connected at ground point. So, suppose if this probe is dipped or immersed into the water, here the voltage will be 0 volts. Okay. So, even if I have connected these 5 volts through some resistor values, say some 1K or 2K, so this voltage here will be 0. Okay. So, if you want to directly connect this voltage to PA naught, this will use negative logic. To convert this negative logic into positive logic, I have connected through inverter. So, this will be 1. So, whenever this probe is inserted here, this will be 1. If this probe is not inserted, this probe is inserted implies the port value PA will be having value of 1, because before the inverter it is 0, after the inverter it will be 1. If probe is not inserted or not immersed, implies that port value will be 0. Okay, that is the logic. If this particular probe is immersed, so I will assume that this is, say for example, for the sake of simplicity, 1 centimeter. If both are immersed, first one and second one, this is 1 plus 1, 2 centimeters. This is total from here to here 2 centimeters. And if third one is also immersed, I will assume that this is, say, some 3 centimeters. Okay. So, like that I can display the values of this 1 centimeter, 2 centimeter on this 7 segment display. In addition, so I am going to control the on and off of this particular motor also. Say I want to control, I want to maintain the level between 2 centimeters to 6 centimeters. Means, so whenever this level is less than or equal to 2 centimeters, implies I will on the motor to pump the water. Okay. So, between 2 to 6 centimeters we will not do anything. If this level is greater than or equal to 6 centimeters, then I want to maintain between 2 centimeters 6 centimeters, I will off the motor. So I want to display this value on this 7 segment display. In addition, I want to control on and off of this one through this motor control using PC NOT. Okay. So you see the hardware setup, the connection from 8255 to 8086 we are not showing because we know how to interface 8255 to 8086. So with this assumption, how to program this, what will be the program for this? Here in this we are using all the 3 ports, port B as output port, port C of course only one pin only output port, port A input port. Let us assume that all I want to operate in mode 0. So what is the control word register? This is port C lower, I want to ask output port 0. Port B, I want the output port 0, mode selection for port B 0, I want to operate in, this is port C upper, I want to have the output port, and port A I have to operate as input port, and mode selection for port A will be, I want to operate in mode 0, and this will be 1 for bit set, control mode CD, so it will be this one 9, this will be 0 90H. So the initialization of this stack pointer, data segment, all these things I am not writing because here we are going to call the subroutines. Wherever subroutine is called, we have to initialize the stack segment, and for any program you have to initialize the data segment, and whenever you want subroutine you have to also initialize the stack pointer also. Stack segment, stack pointer in case if you write the subroutines, and data segment for all the programs, okay, that I am skipping here. So initially I have to set this 90H into the control word register of 8255. The instructions are move AL, 90H, out FFH, AL. So with these 2 instructions, the 8255 will set this port B and port C as output ports, port A as input port. Okay. Now the next step is, so we have to see which probes are inserted. Total I am using 8 probes. Okay, corresponding to each pin, each line we have 8 probes. Okay. So which probe is inserted? So in order to check this, total 8 probes are there. So I will initialize move BL, 00, so that I will start with whenever a probe is inserted I am going to increment this value. Then move CL, 08 because total we have 8 probes. After each probe checking I will decrement the CL by 1. Okay. So I have to check now the contents of the AL because this is connected to port A. Okay. So in AL, FCH, FCH is the address of the port A, this is FCH. So with this the status of all the probes will be available in AL. Now you have to check the lower first, PA naught. PA naught is connected to lower order which is correspond to 1 centimeter. Okay. So PA naught, to check the PA naught is 0 or 1, rotate the accumulator contents to the right, ROR, this will be through carry, AL, 01. So take the contents of, you can take RRC because I want the carry contents also, you can use RRC. So this PA naught contents will goes to the carry as well as carry flag status as well as PA7. Okay. So I am going to check now carry, jump, not carry, down. What does it mean? Not carry means there is no carry, means AL contents are greater. Okay. So RRC, if jump not carry, no carry, means AL will be, so the last PA naught is 0. So PA naught is 0 means no need to increment, we have to go check for next PA1 and so on. Okay. If this is false, jump not carry is false, means PA naught is 1. So you have to increment BC, INC, BL, because PA naught is 1, already 1 centimeter. Similarly, you have to check for PA1, if it is also 1, 2 centimeters. PA2 is also 1, 3 centimeters and so on. So we are incrementing the BL, otherwise you have to go for the next down. At the down, what you have to do, without incrementing the BL, I have to go for the next rotation. So which will be, you have to decrement CL by 1, DEC CL, jump not 0, up. So how to check the next probe. So where that next probe checking will be done, again you have to rotate by one more bit. While this is coming out of the loop, BL will be having the number of probe immersed into the PA. So at the end of this loop, what will be the contents of BL? BL contains the number of probes immersed into the water. Okay. If only one probe is immersed, 1 centimeter, I am simplifying the logic. Okay. We can use other logic also for some complicated problems. 2 probes are inserted 2 centimeters, 3 probes are inserted 3 centimeters and so on. Okay. Now I can go up to the 8 centimeters. So those values will be present in BL. BL is 0, 0 means no probe is inserted, 0, 1 means 1 probe is inserted and so on. Let us assume that there is a lookup table. I am maintaining a lookup table here. Lookup table. Say starting address of this data segment is 50,000 H and with a offset of 5,000 H, means 55,000 H. This offset is 5,000. I will store here a code corresponding to display 0 on this 7 segment display. In 55001, I will store a code corresponding to value which displays 1 on the 7 segment display. In the next location 55002, a code corresponding to 2 display on 7 segment display and so on. Okay. Now at the end of this loop, BL will be having either 0, 0 means the corresponding 0, 0 location we have the 0 code. If it is having 0, 1, in the corresponding 0, 1 location we have 0, 1 code and so on. Means simply the contents of this has to be outputted onto this port B, so that corresponding value will be displayed on 7 segment display. For that, what is the logic? BL is already having this last 2 digits of this offset. Then you represent BH with 50. Now what will be the BX? BX will be having this offset value. If none of the probe is inserted, BL will be having 0, 0 means 50 offset value. If first probe is inserted, offset value becomes 5001. If 2 probes are inserted, 5002. So each location is having corresponding code. So this you read onto the AL, move AL comma contents of BX out onto the port B. Out port B address will be FDH comma AL. So this program will display if no probe is inserted 0 here, if first only one probe is inserted 1, 2 probes are inserted 2 and so on. Okay. So this is about measurement of level. Now to control this, I have to check whether the measured level is in between 2 centimeters to 6 centimeters or not. If it is below 2 centimeters, I will on the motor. If it is about 6 centimeters, I will off the motor. Okay. Further the program will be. Now BL contents, you check the BL contents which with compare BL comma 0 to H. Jump not carry. What does it mean? BL will be having already larger value, means it is greater than or equal to 2. Greater than or equal to 2 means no need to on the motor. If it is less than 2 centimeters, you have to on the motor. Okay. Jump not carry. So you go for down. Down already one down I have written. Write down 2. If this is false, it will go here, means it will check for the upper limit. Now lower limit has been checked. If not, if this is false, what does it mean? BL contents are less than 2, that means level is less than 2 centimeters. Okay. So in that case, this is jump not carry. Not carry means even 2 is also it is not carry. This is only not less than 2 equal to just only less than. This is also greater than 6. Okay. So here what you have to do? You have to write the program to on the motor. So now to on the motor, PC not is connected simply. This is very simple program. Move AL comma 0 1. So the last bit will be 1 out onto port C. Port C address is FEH comma AL. So this will be executed whenever the level is less than 2 centimeters, it will on the motor. If this is not true, then you have to go for down to where you have to check for the upper limit. So upper limit is 6. So compare BL comma 06. Now if it is greater than 6, I have to off the motor. So for that you have to write jump on carry, because here I have to check the less than condition, here I have to check the greater than condition. So I have to write jump on carry. Jump on carry means BL is less than 6, no problem. I have to go for the repeat. So I have to repeat the entire process. If this is false, means no carry, means BL is greater than 6. So in that case I have to off the motor. I have to write the program here to off the motor. How to off the motor? Basically you take move AL comma 0 0 out onto port C. Out port C will be FE H comma AL. This will off the motor. Then after that we have to jump to repeat. This process has to be continuously performed. So jump, unconditional jump to repeat. This repeat and this repeat both are same. Okay. If it is maintained between 2 centimeters and 6 centimeters, nothing to be done. You have to goes on monitoring the program. If it is less than 2 or greater than 6, you have to on and off the motors. Okay. And where should be this repeat now? Repeat will be here. So this is how we can. Here we are doing two tasks. One is we are displaying the value, means you are measuring the level, and second one is you are controlling the motor also. So this is water level control, measurement and control also you can call this as water level measurement and control. Water level measurement and control using 8086. So like that we have plenty of applications of this 8086 or any other microprocessor if you use the 8255 IC. Okay. I will give another example where the traffic light can be controlled. Traffic light control using 8086. I will take a simple problem. So, based on this logic you can extend to some complex routes also. This is 4-way. I want to control the traffic in a 4-way junction. Let us assume that this is north direction. So, this will be south, this will be east, this will be west. Okay. So, I am going to arrange 3 lights. Red represents stop, amber or yellow represent alert, green represents proceed. Okay. I am going to use 3 color lights. So, one is R, G, Y. R is red, which indicates stop. G is green, which indicates proceed. This will indicate stop, this will indicate proceed, and Y represents alert. Yellow, so before going into the red or green, I will make alert yellow. Okay. Similarly, here also I am going to connect 3 lights RGY. Here also 3 lights RGY. Here also 3 lights RGY. Now you have to connect each light to one of the ports of 8255. It is up to you. Suppose if I want to connect this to PA0, PA1, PA2. If I want to connect this to PB0, you can write PB2 in similar order, PB1, PB0. If you want to connect this to PC0, PC1, PC2, then you can use the higher order ports also. I can, or if I can use here PC7, PC6, PC5. Okay. So, now what will be the procedure here is, first we have to make, so the procedure here is first glow or red along any 2 directions, say west and east. Okay. Then simultaneously what you have to do? Glow green along north and south. Now the vehicles can move in these directions. Okay. So, the other direction is from west to east or east to west will be stopped. Then you allow some time called delay. This delay depends upon the traffic condition, okay, density of the traffic and all. Then I want to change the now condition. I want to make this red to green, this green to red. Before that, I will place yellow along all the directions. Along all the 4 directions, west, east, north and south, so that people will alert. The people who are moving from north to south and south to north, they will alert that they are going to be stopped, and the people want to move from west to east or east to west, they will alert to proceed. Okay. Again you call a delay. Normally delay 2 will be less than delay 1, because yellow will be there for only small amount of time. Then you have to reverse the procedure. Glow red along north and south, glow green along west and east. Again delay 1, because this delay from north to south and south to north, it should be equal to west to east and east to west. So call delay 1 only. Then you have to glow yellow along all the directions. W, E, N and S, call delay 2. Then you have to reverse the procedure. So you have to repeat this problem, and you have to go this from here to, again you have to this, you are sending the green on west and east. Now you have to send the green on north and south. So from here again you have to repeat this step, and this is infinite loop. So this will move in a infinite loop. Okay. So here I am not considering the passage from here to here or here to here. Okay. So you can write the program for that also. So here I am considering the only flow between north south and west to east. Okay. So the corresponding program for this we will write in the next lecture. Thank you.